welcome to this afternoon's session on hard to place risks. So back in 1835, property loss prevention was not a top of mind business issue. That is, if your business was hit by fire, flood, or another natural hazard, you rebuilt and hoped for the best. Until a textile mill owner named Zachariah Allen came along and developed an engineering-based insurance model to help better serve those hard-to-place risks, and the birth of Factory Mutual Insurance Company. FM is now a leader in commercial property insurance, helping businesses understand and protect against risk. With nearly 200 years of experience in property loss prevention, backed by science and engineering, FM has a unique understanding of how to transform a hard-to-place risk into a managed solution. In this session, you will learn about the factors that drive risk to be hard to place, methods to obtain better outcomes, and discuss some of the emerging risks that may become hard to place in the future. As Director, Anthony is responsible for the affiliated FM's operations in Australia and New Zealand. Prior to being appointed to his current role in 2021, Tony served as the Group Manager, Account Engineering, where he led FM engineering team in the same region. He joined the FM Global Group in 2004 as a consultant engineer. Tony holds a bachelor's degree in mechanical engineering from the University of Technology, Sydney. Welcome, Tony. And if anybody has any questions throughout, please put up your hand and we'll just happy to take them throughout or at the end.
Yeah, please do ask questions and don't wait till the end. This isn't a scripted presentation. It's a very hard topic to cover, hard to place risk, because you've got such a wide variety of different types of risks that you can talk about. So I've tried to keep it general and give you a few ideas to think about. But like I said, please feel free to put your hand up if you've got questions, if you've got concerns about anything I'm saying. Jump right in and stick your hand up. So as Carly just mentioned, we did start as a textile mill, very different to many other insurers. We started as an insurance company because our original owner just didn't think he had the best outcome from his insurance company. When he looked at what he wanted from insurance, it was more about risk management. He wanted to make sure that his business was going to be safe at the end. He wanted to make sure that he wasn't going to lose his clients and so forth as a result of a property loss. Because when buildings burned down back in the day, it would take years to rebuild. And through those years, you'd lose your clients. And at the end of the process, when you've got a shiny new factory and you've got no clients, it's sort of irrelevant having a nice factory. So he tried to find ways to protect himself, to make himself a better risk. Come on in, everyone. So try to find ways to protect themselves, to make them a better risk. And he hired engineers that could help develop new technologies, things that were going to make sure that his business was going to be in better stead at the end of any particular loss. And it was a very, very successful model. When he went back to his insurance company and said, look, I'm not having losses. I feel like I'm a far better risk now. Can I have a better premium? The answer he got back was no. We need your premium to pay for everyone else's losses. So we can't give you our discount. And that sparked the whole thought of let's become our own mutual insurance company. So he joined with like-minded mill owners that started the Factory Mutual brand. And then from that point on, they've continued to grow. We've maintained that same philosophy. We will continue to try and protect our clients. We do a lot of research to try and find ways to prevent losses from occurring. Whenever a loss occurs, we go back and do the research and try and find ways to protect it and prevent it from occurring again. I've got a couple of photos here just to show you, we failed a lot, right? This was our first test center. We burned it to the ground, but that's the sort of things you have to do when you're finding the right way to do things. But as a result, we got some great technology came out of it. The first fire extinguishers, for example, the modern day sprinklers, they all came out of these test centers. Actually, today we've got thousands of sprinklers that we've patented and designed to make sure that we can protect facilities in any different shape or form. And we give away all those patents for free because we don't want to hold that technology back. We want it out in the market. We want our clients protected and doing the right things. But we don't just do the fire. We look at everything that can potentially happen at one of our clients' facilities, be it explosion in the large scale, at small scale, whether it's wind and construction hazards. If a roof's going to come off, you want to make sure that it's properly designed. So we've got a lot of testing around how to better secure a roof. We spend an enormous amount of money continuing to understand fire and how fire hazards are going to occur and how we can best protect them from occurring in the future. And we do this to try and help those clients that have hard to place risks. Our client base is full of very, very challenging occupancies, and we don't look at them as hard to place risks. We look at them as just a client that has an exposure that needs a solution. One of the other things that we've sort of pushed our way into is making sure that our clients have appropriate understanding of their property. As the generations change and we have people that originally designed facilities now retiring, we've got a new wave of staff coming through that don't necessarily understand how their buildings operate and what the equipment does. We've created these new training facilities where we train client personnel to understand how their buildings work, how to test their equipment and not have to rely purely on fire contractors to say if a system's good or not. And all that very technical equipment that they have throughout their buildings is it's all got to be understood, and that information needs to be passed on from generation to generation. So we're building these facilities to try and help transfer knowledge to the next generation. And again, and it flows into everything from even to flood barriers. Where clients spend a hell of a lot of money on protecting their facility with particular flood barriers, and then the person that installed it goes off and retires and nobody knows how it works. We've got that training facility in there to make sure that they know what they're doing. So as I said, we've integrated engineering significantly into our insurance company. Engineering, we're probably more of an engineering company now than we are an insurance company, even though insurance is what we provide. And that's what I wanted to talk about today. It's sort of enough talking about us. I just wanted to give you confidence that we do a lot of hard to place stuff. This is the full suite of occupancies that we currently insure across the world. Manufacturing being our number one, FM Factory Mutual being our core market is manufacturing, but you can see some pretty challenging occupancies in there. Semiconductor, mining, molten metals, electronics, pharma, food, chem, all really tough stuff, but we find a way to do this stuff and get them placed, and typically 100%, unless they get really, really large. We find ways to do it because we work with those clients to find solutions. As I said at the start, having a hard to place risk, it's really difficult to sort of pinpoint what to talk about. So I've sort of tried to spread the thought as to how we approach hard to place risk just across different parameters. A lot of people think of hard to place risk being a resultant of the construction of a particular property, be it it might be wooden construction or EPS. A lot of people just think about it in terms of occupancy, whether it's a bar or a chemical plant or something that just doesn't seem like it's going to be easy to place. Protections tends to be a big driver as to something being called hard to place if the protection's not adequate. And very likely when you have large exposures from natural hazards, so if you've got flood exposure in far north Queensland or earthquake in New Zealand and so forth, if you've got these sort of exposures, they tend to be hard to place. But having those occupancies or that construction or protection, lacking of protection or exposures, doesn't necessarily mean you're a hard to place risk. What tends to be the reason or the driver for being a hard to place risk is the loss expectancy that's driven around those exposures. Loss expectancy being the actual dollar amount that's got to be paid out at the end and the frequency of which that dollar amount's going to be paid back. And that sort of forms the crux of what insurance companies get challenged with and why they sort of steer away from certain risks. So throughout this presentation, I'm trying to give you a guide to say, identify what factors could result in a large loss and how frequently that loss would likely occur. And that's likely the things that you need to attack when you're looking at a hard to place risk. If you can find solutions to bring that loss expectancy down or the frequency of that loss down, then you're more likely to find a market that's interested in playing in that space. If you look at the traditional market, they use a lot of actuarial models to come up with how they're going to price a risk. It's just a diagram I pulled off the internet, a Monte Carlo calculation, very, very complex algorithms. It doesn't mean anything, so it's nothing to do with our company, but it's just to give you an idea. They come up with these calculations to try and work out the frequency of loss and the size of loss. And from that, they can create their premiums and so forth. It's all backwards looking. It's all looking at the past and looking at the losses that's happened before. It's never looking forward and trying to prevent losses from occurring. And that's the difference in, I suppose, our model to others. we look at what's happened in the past and then we try and change the future, try and make something different so we don't have that same loss history, we don't have that same loss expectancy. And I'll sort of show you how the negative effects of taking an actuarial model could be in a realistic sort of scenario. Now, I'm not a car underwriter or a motor fleet or anything like that. This is purely an example to see how an insurance company might come to the conclusion that a certain market might be hard to place or why it's an undesirable market to play in. So if we're looking at, say, the car market, and you had 5 different options there, you've got standard cars, you've got electric cars, you've got sports cars, Ubers, and race cars. There's obviously a much higher volume of cars in each one of those spaces. So you can see, if you're going to set up a model to insure cars, you might say, well, it's likely I could insure 10 million normal cars, only maybe 1 million electric cars, because there's not many out there. Sports cars, much less, because people can't afford those sorts of things, and Ubers are less likely, they're business stuff. And then the race cars, very, very low number. And when you get into the insurance world, there's a law of large numbers. The larger volume of data that you've got to work with, the more likely you're going to get an accurate outcome of frequency of loss. So they usually come up with this frequency for this sort of calculation. We'll just say they're going to assume it's a 1 in 100 cars is going to fail each year. Is going to have a loss. Again, it could be 1 in 1,000, could be 1 in 1,000,000, whatever it be, but let's, for the calculation sakes, we'll do it 1 in 100. So if you had a 1 in 100 loss frequency on those cars, and then you work out your average loss, right? You work out a typical car's about 20 grand worth of damage, so that's what your typical loss is. Might be a bit higher for an electric vehicle, even a bit higher for a sports vehicle, about the same for an Uber, and significantly higher for a race car. So you can very quickly work out what your estimated losses are for that sort of space. So you could say, for my $10 million worth of standard cars, I'm going to have, what's that work out to be? 100,000 losses at 20,000 each. That's $2 billion worth of funding I need to make sure I've obtained, and so forth. You can work out the sort of rough amount of premium, well, not premium, but loss dollars you need to collect in your premium to pay for the losses that you expect. Then you add an underwriting expense, is typically about 20%, it's for reinsurance costs and all the admin and so forth. Add a little bit of profit and you come up with a total premium pool that you need to collect. So pretty basic maths, right? There's nothing terribly challenging about that. And then you can work out the sort of profit that you could get. So if you look at it, you've got from your 10 million cars you're going to insure, you can likely generate about $264 million worth of profit, down to only about 600,000 for the race cars. So you get a bit of a guide, and that's how you typically sort of set up a business. A lot more complex when you're using your algorithms, but typically following that same sort of process. You roughly work out your frequency of loss and the loss cost, and then you can come up with your premiums. And at the end of the year, you can go back and look at it and see how you performed. So in this example, we might have been a little bit more favourable on a little less favourable, and 1 in 98 cars sort of failed, and the loss cost of 20 grand each, and generated a loss cost of 2.4 billion. So it's a little bit less profit than you'd expected, but sort of in the money. Electric cars, it's an emerging technology, so we might not have picked the loss cost quite right there. And they were a little bit more expensive, an average at $44,000 to fix a car, and a little bit more frequent because the drivers of those cars weren't as lucky. So just with those small changes, we've generated a loss of about 10.3 million. So it's a significant drop off a potential of 48 million profit. Okay, if we do the same thing with the sports cars, and they're a little bit better drivers, they take care of them a bit better. We have fewer losses, and the cost came in a little bit lower, so we could generate a little bit more profit. So it's a favourable outcome. You can see where I'm going here. Those small changes can have massive impacts on the profitability of a particular class of business. You can see there, if your race cars failed a fair bit, you could quite easily have a massive loss of profits just from a small change of a number of frequency, because your numbers are so small. So if you can imagine, if you're an underwriter and you're looking at your portfolio and you start to think, where do I want to put my money? What's a good risk transfer? Where do I want to play? It becomes pretty obvious that if you're in the standard sort of business of doing the high volume, low or high predictability type of areas, it's a good space to be. Very likely to generate profit. You might be in those areas that slightly slightly unprofitable, but you can see a future there. So you might just say, let's put some rates up on that one. We'll adjust our factors. We might make a bit of money there. Another space, you might say, I can drop a bit of premium here and probably still make money. So that's a good space to be in. But these other areas, like you'd look at it and go, yeah, for the potential of making 250 grand and I'm making a loss of $1 million, should I bother playing in that space? Likewise for the sports cars, for a $600,000 potential outcome, I had a $20 million loss. Do I really want to put my capital there? And these are the spaces that people tend to end up being in, those hard to place risks. It's where the likelihood of a large loss occurs and there's a small outcome of profit. It's just not a good business deal. And that's where they end up being pushed out from particular markets, and then you have less and less players that are really interested in it, and prices go up. Not a real good outcome for a client, but we're all in the business of making money, and it's a risk transfer, so it's a give and take sort of relationship. And if that give and take is sort of out of balance, you can see how insurers tend to move away from certain pieces of business. So the factors that are going to change is about changing the loss cost. As I said earlier, if we can work out the frequency and get that frequency set, make it as less frequent as possible, and make sure that we really know what the exposures are, and the exposures aren't going to be terribly difficult to estimate or blow out further than what you expect, you get far better outcomes. When you've got, in our model, we spend a hell of a lot of time trying to work out what that frequency is and what the total loss is. And we use a very, very simple underwriting approach. If it's a poor risk, we use facultative reinsurance and treaty and so forth to make sure that our particular exposure, or what we're likely to see as a loss, is paid by others. So if we had an NLE, a normal loss expectancy of say 250 million, like we don't necessarily want to have that exposure on our books, so we'll buy reinsurance or FAC or whatever it be to cover that potential loss. But if it's a really good risk, that's in office and it's sprinklered and the normal loss expectancy at those sites fairly manageable, we'll happily put our net capacity out on it. And as you can quite easily see, when you start relying on facultative reinsurance and treaty costs and so forth, your price is going to go up significantly, or you might not have any appetite at all to get involved in it. And that's why you tend to have, the more expensive prices in the market for the less quality risks. Our model is all about trying to reduce those NLEs, try and get those normal losses down to a far more manageable number. When you get it down to a far more manageable number, you can use more net capacity, you can use more local market knowledge to get better outcomes for your client. And that's sort of how we've built our whole business model. It's all about working with clients to try and reduce their exposure, get them back into a better place. How do we do that? A lot of times it's something simple like sprinklers. Fire is still the number one driver of loss in the property insurance world. 40-50%, near enough, of all loss costs associated with fire. So we spend a hell of a lot of time making sure that our clients have sprinklers where they should. Now, I'll show you a quick video as to why they're so important. Hopefully this gives you an idea of why we think they're so good.
These two identical arrays each have 12 pallet loads of cartoned polystyrene plastic cups, separated by cardboard dividers. The nature of any cartoned commodity is that the fire develops very quickly on the vertical surfaces. As the fire grows, the heat release rate is increasing at an exponential rate. That will continue until all available fuel finds available oxygen to support the combustion process. When the light grey smoke from burning cardboard turns a darker black, that means the plastic cups with 2.5 times the heat content of the cardboard are contributing to the fire. The two fires represent the tale of two properties. In one case, the property owner has invested in properly designed sprinkler protection and has implemented the necessary inspection, testing, and maintenance practices to assure the sprinklers operate when needed. In the other case, the property owner is still considering making the discretionary investment, since sprinklers are not mandatory building requirements. The presence of a fire detection system, non-combustible building, and local fire brigade have given them a sense of security. As the sprinkler over one array or property begins to gain control over the fire, there is minimal fire, water and smoke damage, and operations will be largely unaffected. This fire will not even make the nightly news. At the other property, a disaster is unfolding. Ceiling temperatures are now exceeding 540 degrees Celsius, and the overhead steel begins to lose its strength. Steel can withstand these temperatures for no more than 10 minutes, and the higher the temperature gets, the shorter the 10 minutes gets. Meanwhile, the fire brigade is still 10 minutes away. By the time they arrive, the building will be full of smoke, the location of the fire will be uncertain, and the structure will be collapsing. They will have no choice but to let the building burn and set up a defensive firefighting strategy in an attempt to prevent fire from spreading to other buildings. This fire will make the evening news. Operations will not be normal for many months, and the business consequences will extend beyond damaged property and interruption of business. Analysts will be asking about the shortfall in earnings and the impact on market share. Relationships with clients and suppliers will be affected. Reputation and image issues will consume executive time. The contrast of the two fires is striking in a matter of minutes. The sprinklered fire is no longer visible, and the unsprinkled fire is fully involved and would continue spreading on adjacent combustibles. Ceiling temperatures exceed 38 degrees Celsius for less than 30 seconds over the storage with the sprinkler. In the unsprinkled array, ceiling temperatures are now over 900 degrees Celsius. It is a disaster. During the course of the video, the one operating sprinkler used 1,000 to 10,000 times less water, a fraction which would need to be used by the fire brigade in their defensive firefighting strategy. This makes it a sustainable device too. Being vulnerable is a choice. By investing in properly designed sprinkler protection and taking good care of the investment so it would work when needed, the property owner chose to be resilient. The fast reaction by the sprinkler system has turned what could have been a major event into a minor distraction.
It's a huge difference in outcome. You can see the stock still sitting on the cardboard from the side that was sprinkled, and the rest is completely gone. So you can see the impact. Sprinklers really do make a difference, but that's only one thing that really drives risks to be considered hard to place. There's so many different factors that could come into play, and I'm sure you've all seen engineering reports and risk reports that various engineers provide, and you contract out to provide those risk surveys, and they come up with a gamut of recommendations. All of those recommendations are likely to have loss scenarios that are typical to what you've just seen, like outcomes that result in total losses. So I thought I'd just run you through a few examples and show you a few videos just to give you a bit of an idea of some of the outcomes that you're likely to see and solutions that you could put in place for those, just so you can know how to sort of pinpoint where losses might occur. I've used a bunch of videos here too, so that freely available on the internet. They're not our videos, they're just YouTube stuff, so feel free to look them up and you'll probably find them. But this first one's a great one. Don't know what stopped. Go back. EPS, very, very tough risk to place, especially if it's unsprinkled. We've all seen the big fires that occur at the large factories, and it's easy to see why there's a shortage of capacity. But I don't think anyone really, well, until you see videos like this, it's really hard to understand why people are so scared of it. So this is a good example, just to give you an idea. So this was just I don't know who did this, it was somewhere in Germany. It wasn't us, put that disclaimer out there. But this is the sort of test that would have originally been done when EPS panels got approved in Australia. Would have put a small fire in the corner next to a panel, ran it for about a minute and said, oh, that's fine, that's approved, it didn't cause a fire, it's non-combustible, so to speak. Sort of the same way that the ACP panels and so forth had been approved for use in Australia. The problem with those panels is if you leave them for just a little bit longer and let that fire get inside the inner core, the fire changes dramatically. So if you're looking at this right now, I don't think anyone would have a major concern running in there with a fire extinguisher and putting it out. But you'll see as the panel sealing comes off and the metal skin comes away, the fire changes significantly. So you now can see that the fire's got inside the panel. and it really starts to take off. Like it's a really, really bad fire. There's you can see why most scenarios end in a total loss when you've got this panel installed in your facilities. You can see why most insurers don't like the thought of insuring it, because an outcome on any building that's installed with this stuff that's not properly protected is going to have a fire like this at some point in its life. There's not going to be much of a building left to, not to mention the environmental impact. That's an amazing amount of smoke that comes out of this thing. And these cool rooms are everywhere, right? They're in the back of little retail stalls. They're in almost every factory that you visit. You just got to make sure that you're getting them. There is better ones around. There is non-combustible alternatives, but there's plenty of undesirable panel out there as well. I'll let the video keep running a little bit longer just so you can get the full impact of the smoke. Very, very scary sort of fire from such a small little cool room panel. But yeah, there's plenty of construction exposures that exist out there. Wood's the obvious one. Wood burns, if you've ever known. So if you've got wooden buildings, they're most likely going to result in a total loss unless they're properly protected. Plastics construction come in all different forms. That's the problem with the ACP panel that I'm sure you're all familiar with. They've all just got a plastic element that will burn. And all the different factors come into play, you know, where it's going to spread to, how easy it is to put it out, can manual intervention come into play, all that sort of stuff. It all matters to an underwriter when they're looking at an exposure and whether they want to accept it. The Grenfell one's a great example of that. You know, huge fire, as you can see, but if you look here, you see the fire brigade's able to get water to the bottom levels. They have that ability to manually intervene, and it does make a difference. The fire only spread where they couldn't intervene. So putting the wet stuff on the hot stuff does make a difference, but as soon as it gets to a point where you can't, the outcomes tend to change. Again, sprinklers are a best friend for all sort of fire scenarios. One of the more newer construction methods that seems to be coming out is cross-laminated timber. A few people might have seen those, and there hasn't been some big losses with those just yet. But you're probably finding it tough to find capacity for those buildings as well, though. Even though they're deemed to be great fire engineered buildings, and we know how to protect wood. That's really great. The problem with those is that manufactured woods swell when they get wet, and you can imagine the frequency of water damage losses in office towers and residential towers everybody knows that they occur very often, but we know how to treat them, right? We dry the place up and we can move on. The problem we don't know with cross-laminated timber is how bad it will be. So if a beam, let's say this property had a leak at the top floor and all the water settled down at the ground floor and sat there for 2 weeks, and then that panel swelled up that was at the bottom floor, how would you replace that panel? Can you replace it? You know, can you just cut it out and put in a new piece of timber? Nobody really knows, and that's what insurers are a little bit afraid of. It's that potential for really big losses from what historically has been a high frequency event. Water losses happen every day of the week. You just hate to think that one of them is going to result in a total loss of a building. That's why insurers get a little bit scared about it. It's that high frequency event with a potentially large loss. Occupancy hazards are probably the biggest driver of causing risks to be stuck in that hard to place category. And it doesn't matter what occupancy you're in, there's always a history of loss or a frequency of loss that's occurred in that industry. The first one I've put up is machine shops. Machine shops or just metal workers and that sort of stuff. Not typically a hard to place sort of risk because they're seen as fairly benign. But there is certain factors in those facilities that can make them hard to place. If you've got hydraulic packs, and you're probably typically seeing recommendations to put shut-off valves or some mechanism to shut off a hydraulic pack in a property. Does anyone understand why we ask for that sort of stuff? Probably haven't seen a loss involving one of those, so let me show you what one looks like. This is, you'll see up the top, right in the middle, a hydraulic hose burst. The oil sprays down on a hot surface, starts a fire. Once that fire starts, it goes very, very quickly. I was really surprised when I seen this video, how quickly it went. Went from a nice casual day to a really bad day in a matter of about 30 seconds. Yeah, I know. Like that's a really scary scenario, and I'm sure there's people in an office somewhere attached to that building that have no idea that that's happening out in the warehouse or in the factory. But again, very, very simple solution to fix. You know, a shut-off button. When the guy, instead of running over to get your phone, you could hit the shut-off button and shut down the hydraulic pack. It's pretty simple stuff. But unless you're thinking about it, because people don't think this way, right? Every product or every machine that's set up, it's not set up to shut down at a drop of a hat, because they're not thinking of those worst case scenarios. They're thinking of efficiency and making sure this thing goes on forever. The thought of having a stop button that's going to shut everything down is a little bit scary, because if they accidentally hit that shut off button, yeah, they could stop the whole production line. But they've never thought through those scenarios to why they need to have some sort of protection, because protection is just as important as maintaining that efficiency of continuing a business. This next video it's a really interesting one for me. You'll note that it's very old. We think we did this video in the 1940s. This is one that we created, and we haven't done it again because the impact of it was pretty significant. But flammable liquids, ignitable liquids, we see them everywhere we go, in warehouses, in factories, in pretty much every manufacturing process has some sort of flammable liquid, but I don't think everyone fully understands how bad those things can be and why we all get a little bit scared of them.
Such great care? Let's answer that question by setting up a demonstration to show the tremendous power in a drum of gasoline. When gasoline or any other low flash point liquid is ignited, it flashes into flame instantly. The intense burning produces tremendous heat. When this heat affects the other drums, something is bound to happen. What you see here is the tremendous power released by only 40 gallons of gasoline, the bursting of a single drum. You can well imagine what the result would be if this uncontrolled power were released inside the buildings of your plant.
It's a pretty big explosion, isn't it, for one drum? It's a lot bigger than I would have ever envisaged, and it's 5 minutes. Okay, I'm running out of time. Better go quick. Very easy solutions though. Sticking on a hydraulic bun, a bun, just to make sure it dispels the liquid before it blows up. Every exposure likely has an engineering solution that can make it safe. It's just about finding that right solution and making sure that you've got use of that solution in place. Another common one is, I'm sure you've all had those electric scans done of switchboards, and you find hot spots, and you find out. Do you know what happens when you don't address those sorts of things? Here's a transformer that had a switch gear that failed. The transformer's full of oil. Once that oil finally erupts, then you tend to have bad outcomes. You'll know when it erupts. It's a big explosion, right? A lot of the things that we do in anything that's a little bit odd can result in large losses. And very easy solution. Just upgrade your switch gear, identify a hotspot, get them changed. Anything I'm telling you here, there's not rocket science behind it. It's just about understanding how to find the solution to fix it. In the interest of time, I might skip past this one, but if anyone wants to see it, I'll show you at the end. This is just an aerosol fire. This is just to prove that just because you've got sprinklers doesn't mean it. I'll just show it to you. Just because you have sprinklers doesn't mean you've always got a right outcome. Sprinklers aren't designed to protect buildings all the time. A lot of the times they're just designed to get people out of a building, to make the building safe for people. But if you were to let the fire run and just purely rely on the sprinklers to put the fire out, it could result in a total loss. I don't know where my sound's gone on this one. But if
1.5 seconds, several more ruptures.
turn that one up a little bit.
Flames still spreading above the top of the array. Or the fire still appears confined to the main flue spaces. 13 seconds, barrage of ruptures.
You can see she's getting a little bit concerned.
20 seconds, control reports 4 sprinklers are operating. Continuous barrage of ruptures. 30 seconds. Fire still appears to be confined primarily to the bottom tiers. It's a continuous barrage of rupturing cans.
We almost burned our test facility down on this test, and a few others as well.
All right. 4 minutes. We have more than 7 sprinklers operating. We have a continuous barrage of rupturing cans. We've been preparing to terminate. We're going
You get the point. Sprinklers don't always work. They need to be adequately designed for the commodity, and that's why you see a lot of times recommendations to upgrade sprinklers to make sure that they're appropriately designed for what you're trying to protect. The presence of sprinklers alone is not always going to be adequate for you. How much time do we have? 2 minutes. Okay, I'll just skip through a few of these. I think we all understand the exposures connected with natural hazards. If you've got a natural hazard, you need to find a solution, and there's plenty of them out there. Hard to place risks are only a solution away. You really need to be thinking of them as someone that needs a partner in a risk transfer, someone that's going to help you find a solution. I'll end with one last video. This is Hershey's, one of our clients. They understand the importance of partnering. They worked with us to create this video just to get a feel for how a client should be thinking about risks when they're hard to place.
Hershey has only this particular plant that is in this part of the world, and this is the single largest investments they have put in because we really want to cater for the consumer demand. We work very closely with FM Global to make sure that this facility is highly protected and manage our risk against all the 5 elements.
Over the course of my career, I've had multiple clients experience debilitating fires, and they're game changers in a lot of ways. Not only impedes financial performance of a company as well as cripples production, it also has an impact on the employees themselves as well as the community those production plants support.
In the early stage of these projects, our Hershey risk management team is working hand in hand with FM Global personnel to identify the risks and also come up with the solutions.
Protecting a facility anywhere, that's one of the most important things you could possibly do. But protecting a facility where no water or infrastructure exists proves to be an even more difficult challenge.
We had ESFR sprinklers out in the storage area. We had to be concerned about dust explosions in the process tower. There was a roadway built to separate these buildings, which allowed them to get firefighting vehicles in between the buildings.
We also utilize the wealth of knowledge that FM Global has obtained from their research campus whenever we decide which types of products we're going to be using in our facility. I mean, that really does give us the confidence that we know how they're going to respond in the event of a fire or another type of incident. Resiliency is crucial to Hershey. Hershey has been a widely known company for over 125 years, and we have to deliver quality to our consumers. So being resilient is a very important part of that process.
We have this facility highly protected and also meeting our vision that is bringing joy and affordable snacks to everyone in the international markets.
I suppose in conclusion, like I said, it's just about finding solutions and convincing a client that they need to take that path of resilience rather than purely relying on insurance for risk transfer. So thank you. I won't go through the rest.
Do we have any questions? Oh, sorry. Do we have any questions? No. No. Oh, we got one here. Yep.
How are you addressing the transition chain for renewable solar panels, battery
Yeah, so we have 3 or 4 divisions within our company, and we've just started a brand new one purely to look into those sorts of risks. We've done a lot of research into all of them. Could have showed you a great video of it. We're working with a client in Western Australia on lithium mining. And we've done some amazing amount of research with regards to solar panels and hail. That's what we see as the number 1 loss driver for solar panels. But it's just new technology, so we're trying to find our feet with it. We are bringing out approved products. We've already got various standards on how to design and install battery installation facilities. So it's just another hazard that we're addressing right now, but it will take a little bit longer before we got the full solutions. But again, it's hard to place because we don't know the outcomes. We have to start thinking of solar power like power stations. They probably need specific wording. if you're getting to that size where you're actually producing power, and that's a mind shift as well. We've been thinking of solar panels as just panels on top of a warehouse or a roof. As soon as you get to that point where you're generating, let's say 2.5 megawatts of power, you're really a power supplier, and you need to start looking at wordings that are around contractual obligations and so forth. So it's not a typical ISR risk. We just got to make that transition. But yeah, we're working towards solutions. Any others?
You mentioned the solar panels, and that's all industry, the PIR panels. Where do you guys situate them from a...
Yeah, so for everyone else's knowledge, we have a division called FM Approvals. FM Approvals exists to approve products. Those are products, we put them through our test facility, we burn them, do whatever they're going to do to work out whether they're a good product for use. And if they're a good product for use, we give them that stamp of approval, and there's an approval guide on how to install them and maintain them and so forth. There is a whole series of approved panels. Most of them are PIR, polyisocyanurate, which is still a plastic, but it's a plastic that needs another combustible there to continue the burning. So we will insure them as long as it's one of the approved products. Typically they require sprinklers for the occupancy they're protecting. So if the occupancy is non-combustible, let's say it's a sand plant and all you're doing is storing sand in the building and you had PIR panels, wouldn't need sprinklers. But as soon as you put something that's combustible in those buildings, you would need sprinklers to, as I said, those panels will burn if there's something around it that burns. So yes, that is something that we were integral in changing the industry, I suppose, in finding solutions for EPS. And there's some others as well, rock wool and some other products as well. Any others?
Thank you.
Thank you, everyone.
Thank you very much. Appreciate that. Thank you all.